Hi guys, so today we will start with a new question number 8, which is to write a Python program that determines the location of a saddle point of a matrix if one exists. So basically what is the saddle point? An M cross M matrix is said to have a saddle point if some entry Aij is the smallest in the value in row and largest in the value in J. So let's just copy this question and move on to our text editor, and let's just discuss this a bit. So let's just paste this and save this file as question q8.py, and let's just comment this out. So then let's just move on to our board and let's just see what did they mean by that. So first of all, let's just create a simple matrix. So 1 2 3 5 8 9 9 4 2 1 1 2 8 maybe. So these are some random values. So what we have to do is, if any element a of I j exists such that the value is smallest, that value is smallest in I row I, so basically row I, and largest in column J. So let's just check. So basically how would I check whether any value is lowest in the row and largest in the column or not? So what I can do is I can store each smallest value of row somewhere. So smallest value here is 1, smallest value here is 2. Let me just change the color. So smallest value here is 1, here is 2, and here is also 1. Okay, so location is 0, here it is 0 1 2 3, and here it is 0 and 1. We can choose anywhere. So let's just see the maximum element in the column. So here it is 8, here it is 9, here it is 4, here it is 8 again. So can we see any common element between this? 8 and 0, no. 4 and 3, no. 9 and so instead of checking single, so what we can do is the same, no. Is the same, no. Is the same, no. So is the same, like this we will go on checking, and if we found some, then that is the saddle point, but there isn't any in this matrix. So what will we do is, let's just create one matrix which has a saddle point. So in the row it would be smallest, so let's just take 3. So 3 would be the smallest, and this column it would be the largest value. So let's just take 2 here. So now here 3 becomes the largest and here 3 is the lowest, so means here that should be some value greater than 3. So 8, and let's just take 5. So here it is the smallest value in row I, smallest, and here it is the largest in the column J. So J is equal to 0, and here I is equal to also 0, and here there can be any value. Let's just take 4 and 9. So here the maximum was 3, here maximum is 8, here maximum is 9, and in this row the minimum is 2. So there aren't any other saddle point. If we wanna make any one saddle point, then what can we do is we have to modify some values. So yeah, here we already have a saddle point, so let's just try to create this as a saddle point. So what can we do is for or this value should be minimum in this row. So what I can do is, instead of 4 I can make this 1, because it would be then minimum value. Similarly it should be highest on this row, so I can make this -8 and this should be 1. So here what I get is largest is 1 and smallest is also 1. So this is another saddle point in this matrix. So like this we have to check if any saddle point exists, we have to print that. So basically that's the question. So how will we do this? So here, as we stored row number and column number, and we saw whether this exists or not, similarly we have to do the same thing. We have to store smallest values of row in somewhere, and we have to store the highest value of column somewhere, and then check if there exists some value. So then if 3 and 3 exist, then there may be a saddle point. If 3, again there is some 3, then if this exists, then there is a saddle point. So basically we have to then check whether exists or not. So the values of m are m equal to 2 minus 8 3, and then the value was 2 minus 8 5, sorry, 3 minus 8 5 and 2 1 9. 3 minus 8 5, 3 minus 8 5, and 2 1 9. So this was the basic matrix which we considered. So now we have to check for the saddle point. So first of all, I will check minimum values in the row. So what will I do is I will create a min function, so minimum value, or you can also implement this on the go, but maybe that would confuse a bit, so I am directly implementing this. So I'll pass an list and I will find the minimum. So what I can do is I can take a minimum value, so min row equal to, let's say, L of 0. So I just assume that is the minimum, and then for I in L, so I will look through each element. So what if I is less than min row? So I got a value which is lesser than the assumed value, then I will just change it, so replace it, and then at last I will return this min row. Similarly, I will create a function for maximum too. So I'll just copy paste it here, change this symbol, and instead of min row, yeah, so we'll change all the occurrence of minimum. So max underscore this thing. So instead of row, it should be column. So column, and here it should be val. So yeah, this should work for I in this. I is greater than max goal. Yeah. So what we have to do now is basically now loop through this element. So for each row, so for I, so for, let's say, instead of looping through ranges, what we'll do is we will directly access. So for each row in list m, so what will we do is let's just create a row list, row minimum list, empty list, and then column max list. So this two would be the list. So what will I do for each row? So for each row, what I will do is I will calculate the minimum value and insert it in that row minimum list. So row minimum list dot append. So what I will append, min value of this current row. Okay, so this was simple. But for column, how should we check for column? So what would we have to do is basically now take two variables. So for I in m, sorry, I in range m, length of m. So now I will be the row count. So then for j in range, or let me just explain this a bit. So instead of this, we can directly do using a simple trick, but let me just show. So here if I just consider this, so let's just take 3 2 1 5 8 6. So here it is 0 0 0 1 0 2. This is 1 0 1 1 and 1 2. Here you, so here as we can see the row number changes. Here it is 0, here it is 1. If there were more rows, 2 3 4 etc. So the row number changes but the column numbers remain same. So it is 0, here also 0, here also 2 0 3 0. So column numbers remain same. So what we have to do is we have to change this row number and we have to keep column as same and then calculate this maximum from this elements. So what can we do is, so we'll just head on to a code, and for let's just say I in range the length of m, and then for j in range length of m. Let's take this one now, maybe this should change. So we'll first write this and then we will see the values. So what will we do is basically we will keep take the list, we'll keep the first value changing. So here the changing value is j, so I remains constant for this loop and j keeps changing. So what can we do is I can take j and then the constant value I, and I have to put this in some kind of list so that I can then calculate the maximum value. So I will create a column list where all the columns will be stored. So column underscore list equal to empty list. Then what will I do is column underscore list dot append this value m of j and I. Then at last what will I do is I will calculate max value from this column list. So column underscore list, I'll find a max value from this column and I will push this or append this into the column max list. I will append this, and yeah, then let's just print this column and row value. So row minimum list and column maximum list, but we have to see what this value should be. So here I is the constant value. So what is the constant value? It is the column number, and here the changing value is the row number. So now how to find column and row? So for column and row we can directly find this out using the matrix itself. So we'll just create these variables and let's just see how we can find this value. So here let me just take this up and I will create a new value 1 2 3. Let me just create this as a list. So 1 2 3 and then 4 5 6. So here can you see what is the size of this matrix? As per me it is 2 cross 3. Okay, so here if I say this is the M matrix and if I calculate the length, so what will length calculate? Length will calculate the number of lists it present. So here is one list, here is two lists. So what this represent? This is the row number. So how did I calculate? Row is equal to length of directly the list which we are seeing. But now I have to calculate for the column. So how can I do this? So column is basically this one and this one. So here I can see it is basically the number of elements present in the inner list. So if I can somehow access this inner list, so how can I access this? M of 0 or M of 1, M of 2. I can directly access any of this value using this index. So this is one of the list. So if I find the length of this will give me column value. So you can just check M of 0 means this list. If I check the length of this list, it is 1 2 and 3. So 3 is the column number. Yes, correct. And if I directly check the length of this matrix M, it is the number of row. Yeah, so basically I'm getting both of this correct. So I will update this in my code, and column would be length of M of 0 and here it would be length of M, row number. So now this should work fine and we will get row and column value. So here I am getting minimum is -8 and maximum is 319. So yeah, so basically we have 3 columns and 2 rows, therefore we are getting this. So now what we have to check is if there is something common in this both list. So let's just implement a for loop and check whether it is column common or not. So for I in, let's just take row min list first. So row min list. So for I in row min list, what I can do is if I means the number, or instead of I, let's just take this as number. Okay, so okay, this just a second. So for num, so for number in row min list, if this number is also present in the column max list, means we have a saddle point. So print saddle value equal to this thing. Let's just use format string and let's just print num. If it isn't present, then there isn't any value. But maybe let's just see a question once again. They need I and j maybe. So an m cross m matrix is said to have a saddle point if some entry a and j is smallest value in the row, and write a Python program that determines the location. So as they have asked the location, what we can do is let's just how we can now calculate the location. So here I can get the value of 1. So yeah, from this number what I can get is I can get the index of 1, and similarly from column max list also I can get the index of 1. So what I can do is I will basically instead of looping through this directly, what I will use is I will use indexes. So for I in row max range of length of that thing, so range of length, so first of all this length of this value. So now I will loop on index. So num will be nothing but num will be row min list of I, means I am using indexes. So here I got the ith value, and what I can do is if num in column max list, so if it is present, then what I will do is I will take j is equal to column underscore max underscore list dot index. So I will find the index of this number. So I can directly find this number. So this will be j. So I can print I and j also. So a of, let's just say I, and then let's just say j equal to this value. So also the square brackets. Yeah, so let's just execute this. So saddle value is at 1 and 1 position. So let's just check here. So this is 0th position, this is 1. So let me just, okay, it is written there. So if we come here and check the position of that thing, so here you can see the value. Let us see. So here you can see let me just point out that, so this is 0 0 0 1 0 2, and this is 1 0 1 0 1 1 and 1 2. So basically now I am getting this saddle point value. Similarly, if there exists any other number also, it will point it out too. So like this we can found the saddle point in n matrix, m cross n matrix. So this was the way how we can find. Now you can take this matrix, you can take this matrix value depending on the user. How you can do that is, so first of all you can take the row count. R is equal to int input. So we'll print a message, enter row count, and then he will enter that. So column would also require the same. So int input, enter column count, and then we have to create an matrix of that size. So m equal to 0. So first of all we will create a row. So in row how many zeros should be there, means we are checking for columns. So basically okay, this should confuse a bit. So we are creating a column at first, sorry, we are creating a row. So in a single row how many values should be present? So column number of elements, so 0. So I'll use list comprehension for I in range the C, so I can use this C. And then similarly this row, how many times this single row should be present? It should be present R number of times. So this list for I in range R. So what will this do? This will create a list of that size. And then so for I in range row, so I in range row, and for J in range J, what I can do is I can basically ask for the input. So m of I j, I will ask int input, enter value for m of, let's take this, yeah, so enter value for m of I and j. So this should be format string. Let's just put f and let's just execute this. So it is asking row count, let's just say 2, column count 2, and okay, so j is not defined, this shouldn't be j, this should be c. So column count, so 2 comma 2, it is asking for 0 0, let's just put 1 2 3 4. So there is a saddle value at this point, so 1 3 and 3 4 1 0. So this is a saddle point, so 1 2 and 3 4, like this. It is a saddle, minimum in the row and maximum in the column. So like this, if there are multiple saddle points, it will identify all of this. So this way you can take the dynamic input and find out the saddle point in a list. So this was the basic program, how we can do this. So for this session this would be all, and we will come with a new question in our next session.